to the next session on MATLAB Advanced. In this session, we are going to discuss about the polynomials that are to be solved using MATLAB software. MATLAB represents polynomials as row vectors containing coefficients ordered by descending powers. For example, the equation p of x is equal to x raised to 4 plus 7x cubed minus 5x plus 9 could be represented as p is equal to 1 is the coefficient of x raised to 4, 7 is the coefficient of x cubed. After x cubed, there should be x square, which is not seen here. So we can also write this as 0x square. Over here, we can also write plus 0x square. So 0 is a coefficient taken here for x square. Then this is a coefficient for x, and this is x raised to 1, and this is x raised to 0, which is nothing but 1. So this is x raised to 4, x cubed, x square, x raised to 1, and x raised to 0. So in descending order of the power of x is the representation of the polynomial in vector form. So this is the very basic of representing polynomials in MATLAB. Next, we will see how to evaluate these polynomials. The polyval function is used for evaluating a polynomial at a specific value. For example, to evaluate our previous polynomial p at x is equal to 4, type this term and then polyval p comma 4. So MATLAB also provides the polyval m function for evaluating a matrix polynomial. A matrix polynomial is a polynomial with matrices as variables. For example, let us create a square matrix x and evaluate the polynomial p at x. So we'll first write down the polynomial over here. So this, when you see, it is representing x raised to 4 plus 7x cubed plus 0x squared. This sign of minus is very important. X plus 9. So this is the polynomial represented here. When you add this semicolon, this means that you don't want to see an output. It is just an equation written and it is just a data given to MATLAB. You don't want to see an output as such. So this will suppress the output. Then you will write down x is equal to 1, 2, minus 3, 4. So this is showing one row. This is the second row and third and fourth one. So you have now shown a square matrix of x, and here you are calculating the polynomial with polyval m p comma x. So we will see these two in MATLAB first. I'll take this to MATLAB. So here you can see it is calculating the value of this polynomial by substituting x is 4. So when you substitute in that equation and you can calculate by using a calculator, you will get the answer as 693. And if you use MATLAB, this is how you get the value. Now suppose if I want to change this value, I can change this to 5. And just paste, so you get the value of this polynomial equation. Substituting x is equal to 5, the value is 1484. So this is just the way of solving in MATLAB. Next we will see this one also. I will take this to MATLAB. So you can see here, this is calculating the value at each place by considering the value as 1, 2, minus 3, 4, and it is giving the value at each position. Next we will see finding the roots of polynomials. The roots function calculates the roots of a polynomial. For example, to calculate the roots of our polynomial p, type this polynomial first and then you will write down r is equal to roots of p. The function poly is an inverse of the roots function and returns to the polynomial coefficients. For example, when you write P2, this is just a variable where you are storing the value of poly R. So instead of finding out the roots, if you want to inversely calculate the equation and find its coefficients, you will have to use this one. So let's check in MATLAB. First I will take this. So you can see here these are the roots, and now if I write the next one, so you can see it is showing the coefficients 1, 7, 0, minus 5, 9. So when you are doing the inverse, you get these terms. And when you give the terms and find the roots, these are the roots. Given the roots, when you want to find the equation, you need to write the command poly. So that's how you find the roots of an equation, or you find the coefficients of the term known the roots. Next, we'll talk about polynomial curve fitting. The polyfit function finds the coefficients of a polynomial that fits a set of data in a least squares sense. If x and y are two vectors containing the x and y data to be fitted to an n degree polynomial, then we get the polynomial fitting the data by writing P is equal to polyfit x, y, n. So that's how you are going to write the polyfit function. So we'll now see, we have script over here. We'll just see. First we'll take x values 1 to 6. That's how you are writing the x-axis. These are the values on the y-axis that I have taken. Now I want to write P is equal to polyfit. So I am trying to fit a curve in this xy axis. xy comma 4. Now here you have x2, which is showing you a range over which you're going to get your curve, that is in a domain of 1 to 6, and this is the difference of 0.1. Then y2 is another variable taken where you are going to calculate the poly variable. This is p and x, that is the relation we are using, p and x2 from here, and that's what you're going to plot xy, and you have x2, y2. And this O over here is actually indicating the point. We'll see once we plot it. And when you write grid on, you will get the grid. If you do not have grid on, the grid will not be seen. So we will just see in MATLAB how this works. Now if you want, you can also have a new script from the left hand corner. You just save it. And say you can call this as A. A is the name of the file, and you save it. Here I will go to the command window. I write A and enter. A is the name of this file, so that's what I am running here. These are the values that I have got that is fitted over this curve, and they are shown with the help of this point symbol. You can see here this is a O or a point symbol, as you can see, and that is what I have shown here, O. So these are the points that are shown over the curve. So you will see here x is from 1 to 6. From 1 to 6, the difference of the 2 points is of 0.1. So that's how you can segregate. These are the major points that you have obtained: 1, 1.5, 2, 2.5. And along the y-axis, again you start from 0, and the maximum value is shown as 1000. And these are the points that you have: 5.5, 43.1, 128, 290, somewhere here. So these are the points that you have fitted. And these are the x points over here, if you can see. So that's how you fit them. And suppose now if I remove grid all, save it again and run the file once again, you can see the grid which was seen in the earlier case is now not seen. So if you want to have the grid on, you can have it, or if you just don't want to see the grid lines at the back end, you can just remove it. So for seeing the lines, you just write grid on, save it once again, enter, grid is on, so you can see the grid lines. So that's how you fit a polynomial in MATLAB. So with this, I end the session. I hope you have understood how the polynomials are solved in MATLAB, how do you get the solution, how do you plot curves. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.